Oh, I see the problem here. It's not. I gotta change the. I gotta change the presentation feed. So here we go. Let's do that one. No, let's do that one. There we go. All right. So now you guys can see this. Yes. There we go. Now can you guys see the quiz?
Yeah.
All right. Good. All right.
Yeah.
So this one's true. It's from -5 to 5 because it says x is less than the absolute value of 5. That means that it's closer to 0 than 5 is to 0. So on a number line, I can turn on the document camera if you guys want. Are you guys okay with this one or not? Because if you're okay, then we won't go over it. But if you want to talk about it, we can. You can let me know in the chat if you want. You can just put yes or no.
Yeah, it's good.
Okay, so we're good. We don't need to go over that one. All right. Okay, good. Hey,
wait.
Ooh,
I
yeah.
don't. Yeah, I don't know how.
You want to go over it? Okay, let's do it.
Yeah.
All right, let's do it. Hold on, let me change. And this thing's weird. Like to change what I'm presenting, I have to like stop presenting and then start again. So let's see here. Unless, maybe I can just do it this way. Screen 2. Let's see if this works. Let's see. So right now, let's see. Once it loads, you guys should be seeing that same quiz. Is that what you guys see right now? Yes. And now you see the document camera. Is that right? All right. So this one says to write this inequality in interval notation. So if we draw this on the on a number line, it's closer to 0 than 5 is to 0, and that could be from 5 to -5. So a graph of this would look like that. So -5 is not included, and 5 is not included, but everything in the middle is. And so that would be interval notation. That would be, it could also be like this. -5 is less than x, which is less than +5. So that's inequality. That's absolute value inequality. This is the number line, and this is interval notation. So these are not included. And it means from -5 up to 5, but those numbers are not included. And the reason that works is because this means a number that's closer to 0 than 5 is to 0. Yeah, absolute value is a distance. So this says x is a number with a distance less than 5. And that's why it can go both ways, left or right. Is that good, Leah?
Yes. Thank you.
You got it. No problema. All right, so let's see. You guys said there were some mistakes in here. Man, I sure hope not, but it happens. Okay, so it says, which of the following statements written in interval notation would match the statement all real numbers between 3 and 8, not including 3 or 8? So that's that one. You guys good? Oh, I bet if there is a mistake, I understand. I know why it happened. I bet. We'll see. But good on that one. So if there's one you're not good at, if there's one you have a question on, or you think that the answer is wrong, you can just, speak up, or you can put it in you can just say something in the chat. All right. Next up, which of the following statements written in inequality notation would match the statement all real numbers between 3 and 8, not including 3 or 8? Wait, is that the same exact question?
No, this one says inequality.
Oh, duh.
Yeah.
Stupid English. So that's that one, right?
But that's
But it's wrong.
That's right. This is it right here. So hold on, let me fix it.
Yay.
Oh man. So I was just thinking right before that happened, like the way you make these quizzes is what you do is like when you make them, there's this little thing right here that says copy it. It copies the answer too, and it's kind of a pain to go back and change it. And I just didn't change it. So that's, yeah. Oh man, what an epic failure. Okay, so interval notation, let me fix that. Let me save it. Okay, that's good. All right, next one. Is this one a problem too? Let's see which of the following matches. That should be this one. Good. And then let's see here. Which statement matches the interval -1 to 0? So this is all real numbers greater than or equal to -1 and less than or equal to 0. So yeah, that's right. That's that one right there. All good so far? This one doesn't have a smallest value. What's the largest value? 5.2. Good. Ooh. All right. Graphs. Dang. Select the intervals where the graph or the function graphed below is decreasing. So it's not all of them, I don't think. It might be. But, well, it probably is on this one because there's two, right? We have one here and then from here to here. And so when we're talking about the intervals, we're talking about the x values. So this looks like it's 0. Oh, so it's going to be -infinity to, whoa. That's totally wrong, huh? I think I see what happened. This should say, oh, these answers are for, I don't know what those answers are for. Oh, wait, this one right here. This works. And then 0.23 to 0. Oh, yeah. No, I take it back. I confused myself. That works. That's it right there. So we're good. Okay, write the interval where the function graphed below is increasing. So it's increasing from here to here and from 0 to infinity. So if you wrote from -5.43 to 0.236 and then from 0 to infinity, you got it right. Here's the problem. You might have typed that right, but like if a space is probably off or anything, it's going to mark it wrong. So that's one of the problems with these Google Forms. Yeah,
that happened to me.
Yeah, so you can get these right. Man, I don't know. I'm just learning how to do these myself, and I should have done this one different. But all right. So next one, interval notation that matches this graph. So -infinity to -3 included. That's good. And then 2 to, so it's this one. Yeah, 2 to infinity. And then this one, oh, what's the range of the function? Write the range of the function graphed. So range is from it's all the y's. So it's going to be from -2 to 2. So it's this. Oops. It's that. Oh, yeah. No, this one. Because it's included and not included. Yeah. Okay, so there was the one mistake, but that was it, I think. Unless you guys thought there was another one, we should really go over it. Were you guys good on that or bad or what? Okay, we're going to assume you're good. Okay, so that quiz, which we just went over, it's due today, so you need to finish that up. Let's see, how many of you guys have done that? Oh, stop it. Let's see. Where is that one? Interval notation quiz due today. 14. Okay, so yeah, you guys are doing good. Almost. A lot of you guys have done that. Good. And then let's see. Due today. I assigned these earlier in the week, so I hope you're already done. The graphing polynomial functions and the function. So how about we do? I'll let you guys tell me. You guys can pick. Okay. Here, let me pull this over here. Look, this is what we got today, right? These two are both due today, and this is due tomorrow. And this one is a worksheet. You're going to have to grade that one on your own. So what if we did this? What if I made one of these due tomorrow? So it could be the graphing the functions quiz or like the studying stuff. Because really that's how this kind of works, right? Like where you read the information, you do the work, you grade your own, you watch the videos. That's really like studying and learning. And then when you take the quiz, it's kind of like showing me what you've learned. Although this quiz is really not very good because I don't know how to make you graph. I don't know how you can show me that you know how to graph. I don't know how you can show me that you know how to graph using an online quiz. But do you want to postpone one of them to be due tomorrow? Or, I mean, if you're working on time, that's fine with me. We could do that. Or if you're okay with them both being due today and you don't feel like you're behind, we can do that. But only 8 people have done this and only 7 people have done that. So I'm willing to give you guys more time. You just got to let me know. I didn't hear what you said, Ruben. It looked like you said something.
I should have waited.
We should have waited.
I stressed out the whole morning trying to get them done because I have so much work to do.
Okay.
Me too. I already did them.
Okay. Well, if you're done with them, then that's fine. I mean, like the quiz won't take you long. This quiz is pretty short. I think it's only 5 questions. And this one, yeah. Well, okay. And then this is going to be later. I'm going to submit it today. I'm going to let it, it's going to be open for you guys to look at today. It's not going to be due till Monday. There's a quiz that goes along with it. One of the things that I've found is, hold on, let's see. One of the things that I've found is it takes me forever to make all that stuff. Like, I don't know, 6 hours or something crazy, which is fine. I'm happy to do it. But so, you know, originally we were going to do like two conferences a day, like one in the morning, one in the afternoon. That's just really not going to work. We could do one a day for sure, but probably it's going to be every other day unless, well, I don't know. We'll try for every day, but every other day we're going to have like a one where we really go over stuff. But that's just kind of how I'm seeing how it's working out. All right, so what I wanted to do with you guys today mostly was go over that polynomial, graphing polynomial function. So I thought maybe a good way to do it was just to try a few and just kind of walk you through it. So let's do that. Let's see. Yeah. I'm waiting for my computer. All right, let's do this one right here. All right, I know it's blurry. Let's see if we can get that to focus. There we go. You guys should see my screen now, right? You guys see the document camera? All right, there's a new hashtag. ITC. So I'm going to, every once in a while, I'm going to write a question and ask you, and that means that ITC means I'd like you to answer that question in the chat box, if you would be so kind. Okay? All right. So let's just make up a function and kind of talk through how we do all of this. So let's say it was 3x times 5 minus x times 4x plus, let's see, that's 0. So I'm trying to think of an x-intercept that's going to be kind of far away from it. So let's say it was going to be 4x plus 12. All right, so let's say we're going to graph this one. You good? All right, so here's what I want to know. I want to know what is the degree. And you can just write your answer in the chat room. I'm going to do the leading coefficient. The leading coefficient is going to be positive, no negative. It's going to be negative 12. We don't even really need to know the number itself, just the sign. So I got one answer. So when you guys figure out the degree of this, go ahead and put it in the chat box. Also, I would suggest getting notes and doing this with me because, man, especially the graphing, this is a really hard thing to learn over distance learning, but you know, if we do it together like this, it might be okay. So you guys are right, 3. You guys are killing it. Okay, so what's the possible number of x-intercepts and then possible number of turning points? So you guys do this one and I'll do the other one. I'll do the number of x-intercepts. So if the degree is 3, we're always going to have 1 x-intercept. So if it's an odd degree, always have 1. The maximum is going to be 3 because it's going to match the degree. And the minimum is going to be 1. So we have 3, 2, or 1. And you guys tell me about the turning points. Possible turning points. Ah, 2, 1. Ah, check this out. I'm glad. Okay. Sorry, it's 2, 1, or 0. If it's odd, it could have 0 turning points. Man, that's good. That's good. So I'm not like happy because I caught you making a mistake. I'm happy because like it's hard. It's good. It's good when you make a mistake and then we can learn from it. And that's a really hard thing to do in this virtual classroom stuff we're doing. But yeah, turning points could be 2, 1, or 0. Now that might seem counterintuitive, but check this out. Let's say we had a cubic function. It would look like that. A turning point, what a turning point is when you go on an interval from increasing to decreasing or from decreasing to increasing. That's when you have a turning point, right? This one's increasing everywhere. There's no turning point. It's going up really, really fast, and then it starts going up slower, and then it goes up really fast again, but it's still increasing everywhere. And so the turning points could be 0 for any polynomial with an odd degree. Okay, there's one last thing we didn't talk about, and I drew my picture right there. So I got this fancy, eraser. So let's get rid of that. End behavior. What's going to be the end behavior of this? You guys know? You can put it in the Google Classroom or in the chat room right there while I erase. What is the end behavior for this function? We'll call that EB. So while you guys write that, you remember how when we would do quadratics, when we do quadratic equations, I would like do this little chart, right? And I like the chart because it helps keep everything organized, like what I need and what I've found out, right? Well, it's going to be similar here, but it's going to look something like this. So you have your degree, your leading coefficient, the number of x-intercepts, number of turning points, and then the end behavior. So do you guys know the end behavior for this one or no? Well, you're all shy now. Yeah, up left, down right. So it's going to look like this somehow or another. It might not have any turning points in the middle. This has 2 turning points, you see. It could go like this. It has none. It could have, let's see, how would it have? Oh, you know what? Man, this is why you got to do crack after school. Ooh, man, it's been a long time since I did this. If it's odd, man, I know this too. In fact, anyway, if it's odd, the number of turning points is going to be even. If the degree is odd, the number of turning points is going to be even. So, and I know better. So I'll write this down for you. You can write this in your notes if you want. Odd degree is going to produce an even number of turning points. Yeah. Yeah. Odd degree or even number of turning points. Okay. So let's go ahead and find out. Let's go ahead and find out our stuff right here. We have up to 3 x-intercepts. And this one we are going to have 3. And we're going to have 1 y-intercept. Always have a y-intercept, right? X-intercepts, you set it equal to 0 and you solve it, right? So that means you're going to have your 3 factors and you set each one to equal to 0. Yeah, just like that. And then you just solve each of them. So here, when you divide by 3, you get 0, 0, right? Oh, wow. And that's going to be the y-intercept too, because anytime x is 0, you have a y-intercept. So 0, 0 is a y-intercept. And we can see that here also. If we put a 0 here and here and here, like we do f of 0 to find the y-intercepts, it's going to be 0 times 5 times 12. Well, that's 0. So origin. Okay, the other x-intercepts, this is going to be negative x equals negative 5, so x equals 5. And this one's going to be negative 3. Right? You solve it, you subtract 12, and then you divide by 4, negative 3. All right, so here's what we got. We got those x-intercepts, that y-intercept, and then we're going to try to figure out the rest of this, right? We're going to check the intervals to see and see if we can figure out how this is going to look. So it's kind of a tricky thing. We have a lot of stuff to put together. We have to check the sign of the outputs on those intervals and see if it matches with what we know. So here's what we got. We got this beautiful graph. So we know it goes through the origin, 0, 0. We know it goes through -3, 0. And we know it goes through 5, 0. Doing good so far? Have I lost anybody yet? I mean, this is really the same as when you were finding x-intercepts for quadratic. The only thing that's different is what you do from here on out. Now we know, it's like Omar said, we know that this is going to go up left and down right, like that. We don't know what happens in the middle, right? But we know it's going to go like this. And even though we say this is up, it's actually going down. This is negative. This is decreasing. So it's kind of a tricky. It can be a confusing thing to say this up, left, down, right? Because the reality is that this is not going up. This is actually decreasing. The arrow just shows that the pattern stays the same, that it's curved and going that way. And then from here, we know it's going down. We don't know how steep or anything like that, but yeah, we know. We know that's how it's going to go. Now, what we're looking for in here, like we have here is where right here x equals -3 and right here x equals 0, right? We're going to try to figure out what happens in between. And so what we're going to do is we're just going to plug in a number. Any number in between, it won't matter. And if the output is positive, then it's going to go up and it would look something like this. You see? If the output's negative, it's going to look something like this. It's going to turn out it's going to have to go down. You'll see why in a minute. I'm pretty sure, 99.9% sure. I haven't done this problem yet. I just made it up myself. But let's find out. So f of 1, our equation was -1. Our equation was what? 3x, 5 minus x, 4x plus 12. So that's going to be -3. Good. We're putting in a -1, so that's going to be 6. And a -1, that's going to be 8. You guys okay with what I'm doing right there? I'm just putting the -1 in for all the x's, and you don't actually need the number. It doesn't matter what the number is. I have a negative times 2 positives. That's negative, so it's going to go down. So f of -1 is negative. That's what that means. F of -1 is negative. So it's going down for sure. Hey, Demo. ¿Qué pasó, carnal? All right, since it's going down, we know it's going to go down, and then it's going to come back up and hit that x-intercept. This turning point, we can't find it with algebra. We can't find it with algebra. We have to use, in order to find it, you have to use calculus. You end up finding the derivative and setting the derivative equal to 0. The derivative gives you the slope. And so when you set the derivative equal to 0, you're finding where the slope is 0. And the slope at a turning point, the slope is 0. And so we have to use calculus to figure that out. So we don't know where it is. It could be, negative. Well, actually, we can figure it out. It's going to be pretty far, like -150 almost. So it's going to be way, way far down, but it is going to go down, and that's all we need because we're just sketching it. Now, from here, I can tell because our maximum number of turning points is 2, it cannot do this because that would give us 1, 2, 3, 4. Our degree is 3, so we can't have 4 turning points. So it has to go up. Here's the other key piece of information. It's really obvious. Everybody knows it, but sometimes it's hard to put it together with everything else. In between here and here, the graph will not cross the x-axis. We found all the x-intercepts. There were 3. We found them all. So it has to go up. We don't know how high or anything, but it has to go up. To check it, here's what you do. To find that out, if you couldn't figure it out from the number of turning points, just pick a number between and plug it in. So this is a positive, that's positive. So when you plug in a 2, your output, when you plug in a 2, your output is positive. It means it's above the x-axis, so it's going to look like that. So everywhere between here and here, the output for this interval from 0 to 5, the output's going to be positive. All right, how's that? How about this? Here's what we're going to try. I want you to rate your confidence with something like this on a scale of 1 to 3. 1 being not so good, 3 being I'm golden. So in the chat room, just give me a number 1 to 3. Let me know how you guys are feeling about this.
I have a question.
Yes, sir.
So you only need to like plug in one number to find like that direction?
Yeah, you only need one number in between. In the entire interval, you just need one input. Because if it's negative, all of those numbers in that interval would be negative, because if one of them's negative and the other one's positive, that means that there's another X-intercept. And we already found them all.
Oh, okay.
Yeah. See what I mean? It's like really weird because this is all the X-intercepts, but like if it's going down and then it ends up back up, then it has to go through it again. And it doesn't. We already know where they all are. So yeah. That's right. So we got a couple 2.5s. All right. So you guys are feeling pretty good about this. It's not too bad. It's really the only thing that's new. Technique-wise, the only thing that's new technique-wise is this part where you're looking for the sign of the output. There's a lot of new stuff with degree. Like all of this is new. Like degree is new. And the number of X-intercepts, number of turning points, and behaviors all new. Leading coefficients not new. Because we did that like with quadratic equations. If A was positive, it would look like this, and if A was negative, it would look like that, right? So that part's not new. But there's a lot of new information, but there's only one new procedure, and that's just checking the sign of the output in between, X-intercepts. And that way you can tell if it's going up or down or whatever in between. So yeah, you guys are doing good. Okay. You guys can let me know if you want to do another one. Yes or no. You can just put a Y or an N hashtag. In the chat room, in the chat box. But I don't even know what you call them. In the chat column. So you want to do another one? Or you feel like you're pretty comfortable with that? So the worksheet, while you guys decide that worksheet I gave you that's due tomorrow, there are quite a few problems, but actually, let me check because ITC, demo wasn't here. ITC means in the chat room, in the chat box, So yes and yes. Okay, we'll do one more. In fact, what I'll do, I'll pick one from. Oh no, stop that. I'll pick one from the assignment for tomorrow. How's that? So this one's due tomorrow. And you guys saw all the answers are, oh, dang, 1, 2, 3. Oh, you guys, you know what? Here, let's go over this right now. Dang, hold on. How many terms are here? 1, 2, 3, 4, 5. So you guys, oh man, I'm gonna adjust this for us right here. You guys can skip number 3. Actually, man, I take it back. We're not ready for this yet. You know what? We're not ready for this because I have to teach you. I have to teach you something new. You guys can do this one. You can do number 4. You can do number 2. You can do 1, 2, and 4 for sure. If this isn't factorable by grouping, the thing I haven't taught you yet that we're going to learn next week is this thing called the rational root theorem, and it helps you figure out how to find the X-intercepts for something like this when you don't know how to factor. So you could do number 8. Is number 8 repeated? That looks weird. It's a problem with stealing stuff off the internet. So here, let me write it down. I'll adjust your assignment for you, right? So you can do number 1. You can do number 2. You can do number 3. 1, 2, 3. Nope. And 8. So here, I'll change it in Google Classroom for us, okay? Glad I checked. I had looked at it, but not well enough, apparently. All right, where did Google Classroom go? Oh, duh. So here's what we're going to do. I'm going to change this one. Edit. Do you want to do one of those three together right now? Or do you want me to just make up another one? We're done with that. So if you want, let's take a look at it again. We can pick number 1, 2. Oh, did I say 3? I hate my life.
Can we do 4?
Yeah, no, yeah, 4. I said 1, 2, 3 when I typed it, and it's 4. 1, 2, 4. Let's do number 4 together. Good idea. Why is number 4 tricky, Ruben?
Well, I was factoring it, but then it gave me a weird number.
Give you a weird number? Did you try factor by grouping?
Yeah, that's what I did, and it gave me, like, the numbers don't add up.
Oh, you know what? It doesn't work. You're right. You know why? You guys can see it right now. There's not a 2 right here with the x squared. So it doesn't work. You can't do number 4 either. You can do number 1, 2, and 8. Dang. Yeah. Oops. So 1, 2, and 8. Well, it's a good thing we went over it then, huh? So 1, 2, 8. I confess it's whose fault is it? It's Hector's fault. No, Hector? Okay, so 1, 2, and 8. There we go. So I guess I'll just make one up. Should we do one that's made up with factor by grouping? Let's do one that's factor by grouping. I'm writing it out so that all right. So let's graph this one right here. Let me turn the document camera on. All right. So let's do this one right here. I apologize about the worksheet. I found it. I looked at it. I thought it was good to go, but I should have looked more carefully. So if you wasted a bunch of time on it, then I'll have to bring you a cookie. All right. But seriously, yeah. Hopefully you didn't do too much. I didn't want to be a waste of your time anyway. It's just you got stuck, but it's going to help you understand what to do next. Well, maybe you can make the connection with what's coming next anyway. All right, so this one right here. Here's what we got to figure out. We need to figure out the end behavior, right? And to figure out the end behavior, you have to do a combination of degree and leading coefficient, right? And then we have to figure out the number of x-intercepts, the maximum number of x-intercepts. And then we also need to figure out how many turning points there could be. And then we got to figure out the y-intercept. The y-intercept in this one's easy, 0, 16. Hold on. Got that crease right there. It's causing me trouble. Here we go. 0, 16. Here's what I want you to do. Let's do in the chat room. I want you guys to figure out the end behavior. Okay, so you guys figure out the end behavior. And the number of x-intercepts is going to be 3, 2, or 1. Turning point, let's see, it's cubic again. So turning points could be 2 or none. Yeah, there we go. So you guys tell me in the chat, what is the end behavior going to be looking like? Anybody but Omar. You got the last one right. I'll give you guys a second to figure it out. What's the end behavior going to be like? Nobody? Ah, there we go. I heard a ding. I'll give you guys a couple seconds to answer. What's the end behavior going to be look like? And I'm gonna look up, see if we got any birthdays coming up. I didn't look for a while. Oh, Daniel's birthday is on Sunday. Man, Daniel, gonna be 16. Let's see who else. Let's see. Seventh period. Nobody. So just Daniel. Daniel's birthday. All right. Okay. So we got down, left, up, right. I agree, Hector. I agree, Demo. Down, left, up, right. So it's going to be down, left. Oh, sorry. Down, left, up, right. It's going to look like that for sure. We don't know what's happening in the middle. Could be 1, could be 2 turning points, could have 3, 2, or 1 X-intercepts. This one I believe is going to have all 3. All right, factor by grouping. You remember, think about factor by grouping. You're going to make 2 groups, right? But they have to be separated by a plus sign. So when we do this, we have to be careful. You see? And then we try to factor out each group. So here we can take out a 9x squared, and we're left with 3x minus 1. Is that good? Now over here, you can actually divide out a negative 16. Yeah? And so you get 9x squared minus 1, 3x minus 1. This one's actually not factored completely because, oh, sorry, that should say 16. This one's not actually factored completely because this is a difference of squares. And this one is completely factored, but watch. It doesn't even really matter. We got it down to a quadratic. If it's a quadratic, we can solve it. And this one, with just one x, we can actually use inverse operations. So we can add 16 to both sides, and then we can divide both sides by 9, right? And then when you take the square root, you're going to get plus or minus 4 over 3. So you have 2 X-intercepts from that, 4/3 and negative 4/3. And here, 1/3. How are we doing on that? Good? I think you guys are okay with that. Like, I believe for you guys, the most difficult part is seeing something like this and knowing that you're going to try to use factor by grouping. Yeah. Okay, so there are our 3 X-intercepts. Let me get another piece of paper. Here are our 3. Oh, there was a fresh one right underneath. That's the last one. So our 3 X-intercepts right there. All right, so they were negative 4/3. So let's say that's negative 1. That's positive 1. So we had 4/3. We had 1/3. And we had negative 4/3. Okay, that's all good, right? And we know that it's going to go this way and this way. We don't know what's happening in the middle. We actually have a clue on this one that makes this easy. You guys recognize what it is? It's going to be your y-intercept. See, your y-intercept is in an interval between 2 X-intercepts already because we had negative 4/3 and 1/3. This is in between, and it's up. So we already know that everything in between here and here is up because we have a y-intercept of 16. So this one is going to go up and then back down. And again, we can't find the exact turning point with algebra. We can like put in numbers and get closer and closer and closer to it, but it's really, really impractical. You have to use calculus, and calculus will give you for this function, we can end up coming up with a formula that will give us the slope at any point. And so we just figure out where the slope is 0 because at all turning points, the slope is 0. All right, now it can't go back up. It cannot go back up because it's cubic, and cubics have a maximum of 2 turning points max, right? And this is already got 1, 2, 3, 4. That'd be 4. That's way too many because this is going decreasing to increasing as a turning point. So this is decreasing to increasing and then increasing to decreasing. Those are turning points. We're only allowed 2. So here, we don't even have to do any work with the intervals. We can just sketch it just like that. So sometimes it works out pretty easy that way. But that's also what makes it difficult is like depending on the problem, you have to adjust your approach. Yeah. All right. How you guys doing with that? How you guys doing with that? Good, bad, what? Leah's good. Good. Yeah, it's not too tricky. I don't think it's too tricky. And the stuff that's coming up, the factoring of the difference of cubes and the sum of cubes is pretty easy too. There's just a formula you just have to follow. So I've assigned that one today. It'll be assigned today. It's going to be due. Let me make sure. It's going to be due. We're going to make it due on Tuesday. So you don't actually have to start it. You don't have to start it right away. But it'll be posted at 3 o'clock. It's going to be posted. And that's going to be due on Tuesday. So that way on Monday, we can go over it a little bit before you turn it in if you want. And that one's going to, it is going to have a Google quiz assigned to it as well. All right. So, okay. I hope everybody's doing well. And I only heard like, okay, so you guys missed out. Like if you weren't here early, like one of the things we're going to try to do, I got this idea from our principal. I think it's a pretty good idea. So when we do our Google meetings, here's what it's going to be. When we do our Google meetings, we're going to start off with like some announcements and stuff like that. But then there's going to be like something to get everybody doing something together. And it just gives us a way to, I don't know, have fun. And so like here, today's prompt was when you log on to write in the chat room how much you love tacos. That was it. So it's always going to be something silly. But I like the idea because it just gives us a way to kind of create some sort of routine with this. And it's also new that it's kind of strange. It's strange for me. And I'm sure it's strange for you guys too. But yeah. All right. So Thursday, tomorrow's Friday. You guys are doing really well. I'm happy with how much participation we're getting. Some people aren't really participating, but those of you who are, you're going to really benefit from it next year. This is all stuff that you're going to have to learn next year, and it's easier to learn it with less pressure because learning takes time and all that kind of stuff, you know. So let's see. There was one other thing. When you're turning in an assignment with your score and you put your, you give me your quick reflection of what was difficult with the private message, that works great. That is so awesome. But sometimes the private messages in Google Classroom, they disappear. So if you just are like working on something, you're not ready to turn it in, you send me a private message, I'll get a notification for it. And then when I open it, it's gone. I don't know why. I don't know what's going on. If I open it on my phone, it's fine. But if I open it on my computer, it just totally disappears. And then it deletes it. So I can't even find it on my phone. So moral of the story. If you have a question for me and you're not turning anything in, email is going to work better. Yeah. All right. So, yeah. So we're doing good. We're graphing stuff. Next week, we're going to start some kind of tricky stuff. We're going to start sum of difference of cubes, and we're going to learn how to do polynomial division. There's two kinds: long division, synthetic, and that might finish out the week. I don't know. Then we've got some complex number stuff that's like imaginary, and then the rational root theorem. Man, got a lot of stuff coming up, and yeah. All right. Well, I hope you guys are doing well. I'm very receptive to giving you more work or less work, depending on how the feedback is. If we're going too fast, or if you have too much work between all your classes, happy to slow down. If you're ready for more, we can do more. I can also schedule stuff a little ahead of time. I'm learning how to do Google Classroom myself. So yeah. So anyway, I can change all those things. Yeah, hey, Zeus is killing it, Demo. Demo's just participating because he's bored. And that was a disparaging comment. It's probably not even true. I was just joking. I'm sorry, Demo. Yeah. All right, guys. Well, if you have anything going on you need, let me know. If we're going too fast, too slow, let me know. I don't know what the best is for this. This is all new for me too. So I don't have a lot of sure ideas of what to do. I know, Demo. I'm sorry, brother. I'm sorry. You know what? I should, man, if we were here, I'd give you a hug. Like, oh man, I'm sorry. You have to forgive me. I was just making a joke. You know, that reminds me though, people are like super sensitive right now. You can't tell jokes to anybody about anything. I mean, everybody's like on edge. Well, there's some people you can joke with, but you have to be really careful about it. You know, during this quarantine, all the jokes have to be inside jokes. I know I already told that joke, but I like refreshed it. But not everybody gets inside jokes. But eventually, everybody will get them, just like the coronavirus. See how I did? See? All right, guys. Happy Thursday. Because all the stuff's due tomorrow, we can meet. You'll have to let me know. I'm not planning on getting together because we kind of went over it all today. If you do have specific questions, though, and we get enough of them, or even just one, really, we can get together. So even if you are the only person that has a question, if I can't answer your question through email, then we'll just do we can do one of these, like a small group if you want. Just let me know. But otherwise, I'm not planning one ahead of time because there's nothing to cover that I didn't already talk about today. And so it's just the rest of the week's just you getting those 3 assignments done. So I'll let you get to it, okay? Anyway, hey, I very much appreciate you guys participating. It makes my life seem like I have a purpose. I know that's why you live, so I can feel like I have a purpose, right? But in all seriousness, you guys are doing good. I'm happy with how you guys are doing. You guys have killed it since day one. And I don't imagine that's going to change anytime soon for you guys. So I'll talk to you guys on Monday. Peace out, brother.
Epic.
N-word.
Love you.
I love that.
So, how far are you on the chemistry?
Chemistry, I'm caught up to today, just barely.
I have to do the unit test, and I haven't taken any of the notes. Any of the notes, I need Ruben to send me the notes.
Wait, like the first unit test?
Yeah.
Oh,
I was
Okay.
barely on this. I was barely on like the introduction to the first ever one we got,
oh,
and I already caught back up. It's not that hard. I did it in like 5 hours. I'm already there. I just need 2 more units after the unit test, and then I'm there.
I'll give you the answers to the unit test. I got 100%.
I just search them up because my brother has 3 monitors. So on one monitor I have like all the answers on Quizlet, and then on the other one I got the needs.
Yeah, like when I'm confused on one of them, I just look it up on my phone.
Yeah.
I hate Ingenuity so much.
I do too, man. I was literally doing. I haven't turned in my coursework.
I haven't either.
I already have it like 3/4 of the way done. I just need to finish the last paragraph, and then I'll turn it in.
Well, I haven't even started on annotating.
Just do the one where like how the author conveys strong conflict or whatever like that, something like that. That one I found to be the easiest.
Maybe.
All right, well, Jesus, I gotta go get caught up with all my other classes.
Yeah, I'm
Since
gonna go play
I'm doing shit. You gonna play what?
Witcher 3.
Oh, that's clean. All right, peace.
Goodbye.